So the topic that the chapter that we are going to start is solution. I have told you solution is a homogeneous mixture of two or more substances. Solution is a homogeneous mixture of two or more substances, right, and form a single phase and exist in single phase. Solution is a homogeneous mixture of two or more substances and exists in single phase. Okay, this is what we call this is what we say as a definition of solution, right? Solution means it should be a homogeneous mixture. Then in solution, I have told you in the last class that in solution, depending upon the number of substance present, okay, we classify solution as binary, ternary, right, etc., etc. So depending upon number of substance present, okay, if suppose a solution contain mixture of two substances, we call the solution as binary solution. If a solution contain mixture of three substances, we call the solution as ternary solution, right? And four substances, quaternary, pentary, like that. So we have different types of solutions based on number of substance present in it. Okay, yeah. And in what we are going to discuss very specifically is about binary solutions. Okay, we are going to focus mainly on binary solution, meaning solution containing a mixture of two substances. Okay, then in solution, very specifically, I am going to consider binary solution. Our focus is mainly on binary solution. Binary solution means it contains a solute and a solvent. Okay, I told you binary solution contains two substances, okay, in which one is a solute, the other one is a solvent. What is a solute? What is a solvent? Solvent is the major proportion or larger proportion present in a solution, whereas solute is the lesser proportion or smaller proportion, okay, present in a solution. Okay, the one which is present in larger proportion is solvent, and the one which is present in lesser proportion or smaller proportion is solute. And this is very, very important in the case of solution, that solvent phase and solution phase should be same. Okay, that is phase of the solution, right, should be same as the phase of solvent. This is very, very important. Keep this in mind. Suppose if solvent is liquid, students listen, if solvent is liquid, solution should also be liquid. Okay, if solvent is solid, solution should also be solid. If solvent is a gas, solution should also be a gas. That's the meaning. Okay, so a binary solution contains two different substances. In this, the one which is present in smaller proportion is called solute, and the other one which is present in larger proportion is called a solvent. Okay, but this is very important point. For solvent, the phase of the solvent, phase means it may be solid phase or liquid phase or gas phase. Phase of the solvent and phase of the solution should be same, right? This is a very essential point you should keep in mind. Okay, now why I am telling this, let me give some example so that you can easily understand. Listen, suppose I'll take 5 gram, right? 5 gram of urea. 5 gram of urea. Urea is readily soluble in water. Okay, urea is readily soluble in water. I'll take 5 gram of urea and I'll take 100 ml of water. 100 ml of water. So here, if you mix these two, if you mix urea and water, I'll get a liquid solution. I'll get a liquid solution. Solution exists in the liquid state. If solution exists in the liquid state, listen, here urea is solid, water is liquid. So which one should be the solvent here? Solution is in liquid state.
Water.
So water should be the solvent here, correct? Because solvent phase, solution phase should be same. So this is solvent here. Okay. Suppose if I take, say, I'll take 1000 gram of urea. 1000 gram of urea. Okay, and I'll put say for example 50 ml of water. 1000 gram of urea and 50 ml of water, right? If I mix these two, right, suppose if I get liquid solution, then again see, this is the solvent. It appears that this is larger and this is in lesser proportion, right? 50, this is 1000, but keep this in mind, solution phase, solvent phase should be same. Water is in the liquid state and urea is in the solid state. Okay, since your solution is liquid, okay, therefore solvent must be water here, irrespective of the amount. Okay, amount is just for definitions, for understanding sake, we say that solvent has larger proportion and solute has lesser proportion in solution. But if the solution exists in liquid phase, solvent must also be exist in liquid state. Okay, so this is the main point you should keep in mind, right? Whether solvent present in a smaller proportion or larger proportion, this is the very essential point you should keep in mind. Okay, is this clear, students? Students, is this clear?
Yes, sir.
Yeah. All of you switch on your, turn on your camera. Turn on your camera. Yes. Okay. Now, so this is a very important point. You must know what is solute and what is solvent. Okay. Now based on the phase in which the solvent exists, okay, you can classify solutions into different types. How? You can classify solution into 3 types based on the phase of the solvent. Okay, based on the phase in which the solvent exists. Okay, right, based on that you can classify solution into 3. What are the 3 types of solutions? Number 1, solid solution. Number 2, liquid solution. Number 3, gaseous solutions. We have 3 types. Okay, students, observe carefully here. In solid solution, solvent should be solid. Your solute solute can be anything. It can be solid or liquid or gas. It can be anything. Okay. So if your solute is solid and solvent also solid, then solid mixture, solute solid, solvent solid. If both are solid mixture, say for example the ornamental gold, right, gold ring or whatever ornamental gold that you are using, it is actually a mixture of copper and gold, right? It's not pure gold. Okay, so copper is mixed with the, in small amount it is mixed with the gold and they form alloy, right? So solid ornamental gold is actually a solution. Ornamental gold, right? See, the gold that we are using, ornamental gold, it is actually a solution. Don't think that solution should exist always in liquid state. No, solution can also exist in solid state. What is the definition? The definition is it should be homogeneous mixture, that's all. Yes, in this copper and gold are present as homogeneous mixture. Therefore, this is an example of a solution. But here solute is solid, solvent also solid, both are solids. Okay, then solute can be liquid in solid solutions, then gas in solid solutions, right? We have many types, right? Like this we have three types, right? Solid, that is solid in solid, liquid in solid, and gas in solid. We have three types of solutions. Then in liquid solution, yes, in liquid solution solvent should be liquid. If I say a solution is liquid solution, solvent should be liquid. So, solute can be solid or liquid or gas. Okay, so here also we have solid in liquid, liquid in liquid, gas in liquid. We have three types of solutions. Similarly, in gaseous solution, solvent should be gas, and your solute can be solid or liquid or gas. Therefore, we have 9 types of solutions: solid in solid, liquid in solid, gas in solid. Then solid in liquid, liquid in liquid, gas in liquid. Then solid in gas, liquid in gas, and gas in gas. Actually, gas in gas, right, is a pure, it gives a homogeneous mixture and it forms a solution. Okay, so we have 9 different types of solutions based on the phase of solvent and phase of the solute. Phase of the solvent and phase of the solute, based on these two, right, we have 9 different types of solutions. But the point that you should keep in mind is the phase of the solution and phase of the solvent should be same. Okay, is this clear, student? Any doubt? Students, is this clear?
Yes, sir.
Yes, sir.
Yeah, good. Now, okay, among these solutions, right, we are going to focus. I have see, these are all binary solutions, right? We are going to discuss only binary solution. Among binary solutions, we have solid solution, liquid solution, gaseous solutions. What we are going to focus is this one. We are going to focus only on liquid solutions here. We are not going to discuss solid solutions or gaseous solutions in this case. Okay, so in liquid solution, yes, we have 3 varieties: solid in liquid, liquid in liquid, gas in liquid, right? So in this discussion, we are going to focus mainly on liquid solutions. Okay, so we are going to focus mainly on liquid solutions. What is meant by liquid solution, students?
The solvent will be a liquid in a solution.
Well, that's all. Good. Good. If solvent exists in liquid, it's called a liquid solution. Simple. Now, before going to learn about vapor pressure and other concepts, okay, let me first give you the method of expressing concentrations of solution, right? What are the methods we have to express concentrations of solution? Concentration of solution. Yeah, we can express concentration of solutions in many varieties. Number one, you can express concentration as percentage mass by mass solution, percentage mass by mass. You can express concentration as percentage mass by volume. You can express concentration as percentage volume by volume, volume by volume. You can express concentration by mole fraction. You can express concentration by molarity. You can also express concentration by molarity. You can also concentration by a term called normality. And we also have what is called ppm, parts per million, or parts per billion, ppb. Right? We have different methods of expressing concentrations, right? Mass by mass, mass by volume, volume by volume. Then mole fraction, molarity, normality, then parts per million. Okay. Listen, these are all a common symbol we use for these concentrations. For mole fraction, we use the symbol x or chi. Sometimes people say that is chi. You can say simply x. Mole fraction is expressed as with the symbol x. Molarity, capital M. Molality, small m. Normality, capital N. Okay, this one is expressed as simply ppm, that's all. Right? All other things are expressed as such, percentage mass by mass, percentage mass by volume, percentage volume. Different methods of expressing concentrations of solution. Okay, now listen, in these concentration terms, right, we are not going to discuss normality. We are not going to discuss normality. We are going to discuss only the other concentration terms. Okay, but I'll just give you the definition for normality and some simple relations, which is very useful for any competitive examinations. Okay. Now, students, among these solutions, the first one where the solvent is not in volume, right? Wherever volume is present, right? If volume term is present, especially solvent in volume, right? In those cases, temperature, okay, becomes a very important term, because as temperature changes, concentration will change, right? So here, among these, which are all the concentration terms, are temperature dependent. Let me write here, temperature dependent. I'll simply put T. T dependent means temperature dependent. Temperature dependent concentrations. Among these, which are all the concentrations are temperature dependent. First one is not temperature dependent. Why? First one is not temperature dependent. Why? Because there is no volume, right? Solute is mass, solvent also mass. So there is no volume. So this is temperature independent. Second one, yes, we have volume here. So it depends on temperature. Percentage mass by volume depends on temperature. Okay. Then percentage volume by volume. Yes, we have volume here. It also depends on temperature. In mole fraction, I am going to define mole fraction where you cannot, you never encounter any volume term there. Okay, there is no volume term in mole fraction, so mole fraction is temperature independent. Whereas molarity, in molarity, I am going to define molarity in terms of volume. Therefore, molarity is temperature dependent. Molarity, I am not going to use any volume here, so molarity is temperature independent. Normality is temperature dependent. Okay, students, keep all these things in mind. These are all very, very important. These concentration terms are temperature dependent concentration terms. Okay, others are temperature independent. Percentage mass by mass, okay, mole fraction, and molarity. Right? Among these three are temperature independent concentrations. Even if temperature changes, concentration does not change. Okay, see what I'm trying to say. These three terms, percentage mass by mass, then mole fraction, then molarity. In these three, there is no volume term involved. No volume term. Therefore, these three concentrations are temperature independent concentration terms. Independent. They are all temperature independent. Okay, even parts per million ppm. They are all temperature independent term, where we don't use volume term. Okay, right. Is this clear, student? Any doubt here? Any doubt?
No, sir.
Yeah, good. Now we'll define, right, these concentration terms one by one. First one, percentage mass by mass solution. Percentage mass by mass. What is meant by percentage mass by mass? Okay, say for example, if I say a solution has X percentage mass by mass, okay, I have suppose X percentage of mass by mass of say some solutions, it contains sodium chloride, right? X percentage mass by mass of aqueous sodium chloride. I have aqueous sodium chloride solution. What is the meaning for this? Student, listen. I'm giving you some percentage. Say X. X percentage mass by mass of aqueous sodium chloride solution is available. What is the meaning? The meaning is, listen. Percentage is there. Students, listen. Which means 100 gram of listen, students, observe carefully. Aqueous sodium chloride, is it solid solution or liquid solution or gaseous solution? Aqueous sodium chloride.
Liquid solution, sir.
So what should be the solvent?
Liquid.
Which liquid?
Water.
That's all, right? Because it is aqueous, right? Therefore, aqueous means solvent is water. Solvent is water, that we know. Okay, therefore you should listen. 100 gram of, what is the meaning? Meaning for percentage mass by mass solution. 100 gram of solution. Okay, solution means total weight. Solution means total weight. Okay, 100 total weight means solute weight plus solvent weight. 100 gram of solution, right, contains X gram of sodium chloride. That's the meaning. 100 gram of solution contains X gram of sodium chloride. This is the meaning for percentage mass by mass. Is this clear, student? Any doubt? Okay, or
No, sir.
okay, ma. Or you can also say like this, that is percentage mass by mass. Percentage mass by mass can also be given as mass of solute in grams divided by mass of solution in grams into 100. This will give you the percentage mass by mass solution. You can say like this also. Okay, this is the definition actually, right? But if solution is given X percentage of mass by mass of aqueous sodium chloride, you must know the meaning. The meaning is 100 gram of solution contains X gram of sodium chloride. Okay. Now, students, take down this. This is percentage mass by mass solution. Now, I'll give a solution. You try to tell me, right? What is the meaning for this solution? Suppose I'll give say 10 percentage mass by mass. Okay, I have aqueous urea solution. Aqueous urea solution. Okay. Yes, students. Can you tell me what's the meaning for this? 10 percentage mass by mass aqueous urea solution is there. Aqueous urea solution. So solution is liquid, right? Aqueous. So what should be the solvent?
Liquid.
Yeah.
Water.
Water. Yeah, good. Yes, what is the definition? Mass by mass means?
Mass of solute in grams by mass of solution in grams.
Very good. Or you can also say 100, okay, 100 gram of solution, 100 gram of solution contains 10%, no, so 10 gram of urea. Both should be in grams. Your solute should be in gram, your solution should also be in gram. Not solvent, your solution should also be in gram. Is this clear, student?
Yes,
okay.
sir.
Yeah, this is the meaning for 10% mass by mass solution. Right, 10% mass by mass solution. Now let me introduce the second one, number 2, percentage mass by volume solution. What is the meaning for this? Percentage mass by volume. Percentage mass by volume. Say for example, if I give a solution, say X percentage of, I have X percentage mass by volume aqueous sodium chloride solution. Aqueous sodium chloride. I am giving some solution which is X percentage of mass by volume aqueous sodium chloride. Can you tell me what's the meaning for this? What's the meaning? The meaning is this. Listen, this second term represent actually solution, right? Solution. So solution is in volume. Therefore, you should take 100 ml. Student, listen carefully. You should not take grams now. You should take in volume. 100 ml of solution. 100 ml of solution contains X. Solute should be in grams. Should be contains X gram of sodium chloride. That's the meaning here. Okay. X percentage mass by volume solution means 100 gram of solution contains X gram of sodium chloride. Okay. Or you can also define like this. Percentage mass by volume solution. What's the meaning? The meaning is this. Mass of the solute in grams divided by volume of the solution. Volume of the solution, not solvent. Student, listen carefully. It is not solvent. Volume of the solution in ml, usually in ml, into 100. This will give you mass by volume solution. Mass by volume, percentage mass by volume. Is this clear? Students,
Yes,
is
sir.
this clear? Yeah, good. Now, just for understanding purpose, let me give you a question here. You try to answer this. Suppose I'll give 10% mass by volume, okay, aqueous sulfuric acid solution or sulfuric acid solution simply, right? Aqueous H2SO4. What's the meaning? I am giving mass by volume solution. 10 percentage mass by volume aqueous sulfuric acid.
100 ml H2SO4.
100 ml of H2SO4 solution
Yes, 100 ml of solution.
and 10 grams of solute.
Well, very good. 100 ml of solution contains, right? Contains 10 gram of sulfuric acid. 10 gram of sulfuric acid. Sulfuric acid is the solute. Water is the solvent here. Okay. So 100 ml of solution contains 10 gram of sulfuric acid. That's the meaning for 10% mass by volume solution. Is this clear?
Yes, sir.
Yeah. Mass by mass means 100 gram of solution should contain some gram of solute. Okay. Mass by volume means 100 ml of solution contains, okay, some gram of the solute. Okay, that's the meaning. Now I'll take the next one, the third one, that is percentage volume by volume. What's the meaning? Percentage volume by volume. Okay, percentage volume by volume. Say, suppose if I give I have a solution which contain X percentage of volume by volume, right? Say aqueous ethanol. Aqueous ethanol. Students, ethanol is also liquid. Water also liquid. So this is actually a mixture of two liquids. Ethanol is liquid, water also liquid. So it's a mixture of two liquids forming solution. Okay. So liquid in liquid solution. Liquid in liquid. Now, if it is given volume by volume, what's the meaning? Solution should be expressed in volume. Solute should also be in volume. Solute should also be volume, because here I have taken ethanol. Ethanol exists in the liquid state. Okay. So what is the meaning for this? The meaning is 100 ml of solution. 100 ml of solution contains X ml of, okay, your solution should also be in ml. X ml of ethanol. X ml of ethanol. 100 ml of solution contains X ml of ethanol. Okay, take down. You can also write like this. Percentage volume by volume is nothing but volume of the solute, solute in ml divided by volume of the solution in ml into 100. This will give you percentage volume by volume solution. Okay, students, yeah, I'll ask a question here. Listen, this compound is actually used as antifreeze, right, in car battery or lorry battery, right? It's actually used as antifreeze compound, right? This compound I'm giving in volume by volume percentage, right? Say for example, if I give 35 percentage volume by volume solution of ethylene glycol, I'm giving some solution, ethylene glycol. 35% volume by volume ethylene glycol solution, right? Solution of ethylene glycol, aqueous solution of ethylene glycol. it is used as an antifreeze in car battery or a lorry or heavy vehicle batteries. It is used as an antifreeze. Okay. Now, what is the meaning for this, student? 35% volume by volume solution of ethanol. What's the meaning?
100 ml of solution contains 35 ml of
Ethylene?
ethylene glycol.
Very good. Good. 100 ml of solution contains 35 ml of ethylene glycol. Ethylene glycol is also liquid. Okay. So water is the solvent here. Right. So the total mixture is a liquid. Your solute also liquid. Therefore, you should define like this: 100 ml. The second V represent solution. First one represent solute. Both should be in volume now. So 100 ml of solution contains 35 ml of ethylene glycol. That's the meaning for this concentration. 35% volume by volume. Is this clear, student? Any doubt?
No doubt, sir.
Okay.
No doubt.
Right. This compound, this mixture, this solution, actually this solution is used as antifreeze. Okay. The freezing point of this mixture, okay, let me write like this: TF means freezing point. Freezing point of this mixture is minus 17.6 degrees Celsius. Minus 17.6 degrees Celsius. What is the meaning? Listen. Aqueous solution in car battery, we actually use aqueous solution. Aqueous solutions usually freeze near 0 degrees Celsius. Okay, aqueous solution usually freeze near 0 degrees Celsius. Near. It is not pure water. If it is pure water, 0 degree, no doubt in that. Since it is a solution, they freeze, okay, usually below 0 degree. Below 0 degree. Now listen, what will happen in winter seasons? Okay, the temperature will usually go down, go below 0 degree in some countries. If it go below 0 degree, then the mixture that is present in battery, it will get freezed. If it gets freezed, okay, you cannot drive the car. You should not allow the mixture to freeze. Therefore, what they will do, they will add this antifreeze in the solution. Okay, they will add 35% solution of ethylene glycol in that. What it will do, if you add this mixture, okay, the freezing point become minus 17.6 degrees Celsius. It will go down. That means even if the temperature is say minus 5 degrees Celsius or minus 10 degrees Celsius, okay, the mixture in the battery never get freezed up. If it go below minus 17.6, then we can't do anything, it will freeze. But till minus 17.6, right, you can save the battery. Is this clear, students? Okay, because in
Yes, sir.
in cold countries, this is one of the major problem people face. Okay, because their the temperature will go below minus 10 and all, right? Till minus 15 or minus 17 you can protect, but if you go below that, it is very difficult. Okay, so we use this compound as antifreeze, right, in batteries. Okay, and remember what is the meaning for percentage volume by volume. For this purpose, I have given one example, right? Many examples are there. Okay, I have given one example here, right? So percentage volume by volume, which means 100 ml of solution. Okay, X percentage volume by volume means 100 ml of solution contains X ml of the solute. Okay, that's the meaning. Now, let me go to the next one. That is mole fraction. The fourth concentration term, fourth one, mole fraction. Mole fraction. I have told you it is usually expressed as chi or x. You can say x simply, right? students, before going to that, I'll give one information here. This is very important. In the case of binary solution, observe this carefully. It consists of solvent and solute. Okay. We generally use number 1 for solvent, number 2 for solute. Okay, in solution topic, wherever if we put number 1, it means solvent. Number 2 means solute. Okay, keep this in mind. This is how many your books also they will follow this. Not only your book, most of the books, right, in chemistry books, if you see, right, this is the usual way of representing solvent and solute. Number 1 represents solvent, number 2 represents solute. Okay, so for mole fraction, we represent mole fraction for solvent, okay, mole fraction for solute separately. So x1 means mole fraction of solvent, x2 means mole fraction of solute. Okay, what is meant by mole fraction? What is meant by mole fraction of, say, solvent? What's the meaning? Mole fraction of solvent means simple, number of moles of solvent. N represent number of moles. N means number of moles. Okay, N1 means number of moles of solvent divided by total number of moles of solvent plus number of moles of solute. Total moles. Number of moles of solvent divided by total moles will give you mole fraction. In binary solution, we have only two substances, one solvent, one solute. Okay, therefore, this is sufficient for the definition of mole fraction. If you go for a ternary solution or quaternary solution, right, then more solute will come, right? What you have to do, you have to include all the moles here, moles of all the components. Okay, in the denominator, right? Is this clear, student? Any doubt here?
No, sir.
No, sir.
Yeah. Is there any volume term here? Is there any volume?
No, sir.
No. Therefore, mole fraction is temperature independent. Mole fraction is temperature independent. Keep this in mind. Then, similarly, mole fraction of solute we represent generally as x2. Mole fraction of solute is nothing but number of moles of solute divided by total number of moles. Number of moles of solute divided by total number of moles. Okay, this will give you mole fraction of solute. Listen, for mole fraction, you should express mole fraction for solvent separately, for solute separately. Okay, you cannot express mole fraction for a whole solution. You have to express mole fraction for solvent, mole fraction for solute separately, right? And remember, mole fractions are temperature independent. Mole fractions are temperature independent quantities. Okay, then in the case of binary solution, binary solution means how many components present, students? What is meant by binary solution?
Two components.
Two substances. Okay, binary component contain two substances. One is solvent, the other one is solute. In binary solution, mole fraction of solvent plus mole fraction of solute, if we add, okay, we have to add the two quantities N1 by N1 plus N2 plus N2 by N1 plus N2, right? In both these term, binary denominator is same, so keep the denominator as such, add the numerator N1 plus N2, so you will get the answer as 1. Okay, so what is the meaning? In binary solution, mole fraction of solvent plus mole fraction of solute is equal to 1. Very, very important, keep this in mind. Okay, in binary solution, mole fraction of solvent plus mole fraction of solute is equal to 1. Okay, this is what we call as mole fraction, right? Then the next one, students, is this clear? Any doubt?
No, sir.
No doubt, sir.
No, sir.
Okay, ma'am, good. Now, how to find the number of moles? How to find number of moles? Okay, let me write in the next page. Yeah, number of moles of a substance. How to find the number of moles of a substance, which we normally represent as n. Number of moles is nothing but mass of the substance in gram divided by molar mass of the substance. Molar mass, sorry, divided by molar mass of the substance. This should be in gram per mole. Molar mass of the substance, which is expressed as gram per mole. So numerator is gram, denominator is gram per mole. Gram cancel, per mole will go to the numerator, become mole. Okay, so if you know mass of the substance, if you know molar mass, right, you can find number of moles. Just for practice purpose, students, listen, 10 gram of calcium carbonate. How many moles are there? 10 gram of calcium carbonate. How to calculate number of moles? So you must know what is the molecular weight of calcium carbonate. Okay, calcium atomic mass is 40. For calcium, atomic mass is 40. For carbon, atomic mass is 12. We have 3 oxygen here, 3 oxygen. For each oxygen, atomic mass is 16. 16 into 3 is 48. So what's the total?
100, sir.
Students, remember, this is very, very important. This is the only compound having molar mass 100. Okay, if calcium carbonate is given, immediately it would come to your mind. Molar mass is 100. Okay, therefore what's the number of moles? Mass is given 10 gram. Mass of the
10 by
substance 10 gram.
100.
Yeah, 10 by 100, which is 1 by
0.1.
10, 0.1. Very good, ma. So 0.1 moles. Okay, 10 gram of calcium carbonate contains 0.1 mole of calcium carbonate. Okay, and you also know this, you might have heard about this, 1 mole of substance. Okay, 1 mole of a substance, any substance, right, contains 6.023 into 10 power 23 molecules or particles. Let me write molecules. 1 mole of a substance contains 6.023 into 10 power 23 molecules or atoms. Because I just generally mentioned as substance. Okay, it may be molecular substance or it may be simple elements. Okay, depending upon that you will get either molecule or atom, but it should contain Avogadro number of particles. This is nothing but Avogadro number. Students, is this clear? 1 mole means Avogadro number of particles should be there. The particle may be molecules or the particle may be atoms. Okay, is this clear, student? Any doubt? So you must know how to find number of moles. First of all, if you know how to find number of moles, then you can easily calculate what is called the mole fraction, because you should calculate number of moles of solvent and number of moles of solute. If you know both, then you can calculate the mole fraction using this formula: mole fraction for solvent and mole fraction for solute. Okay, so to find mole fraction, you must know how to calculate number of moles, right? Keep this in mind, very, very important. Then the next term after this mole fraction I'm going to introduce the next term, that is molarity. Molarity. Take down. Students, take down this very important molarity, which is usually represented by the symbol capital M. Molarity. Right? What is molarity? Molarity is defined as, molarity is number of moles of solute, number of moles of solute present in 1 liter of a solution. 1 liter of a solution. This is the definition for molarity. Molarity is nothing but number of moles of solute. Okay, number of moles of solute. Number of moles of solute present in 1 liter of solution. In 1 liter solution, how many moles of solute present? This is what we call it as molarity. Say for example, if we say I have a solution, say I have 5 molar sodium hydroxide solution. If I say 5 molar sodium hydroxide solution, what is the meaning? The meaning is 1 liter of solution, okay, 1 liter of solution contains 5 moles of sodium hydroxide. 5 molar sodium hydroxide means 1 liter solution contain 5 moles of sodium hydroxide. Is this clear, student?
Yes, sir.
Right? Yeah. This is what is called molarity. You can also define molarity in this way. You can also define molarity in this way. Molarity is number of, instead of mole, I will take millimole. Right? Molarity is number of millimoles of solute present in okay 1 ml of solution. 1 ml of solution. You can define like this also. Instead of liter, here I am using ml. Instead of moles, here I am using millimoles. Okay. So 5 molar sodium hydroxide solution, you can also say like this. Okay. That is 1 ml of solution. 1 ml of solution contains 5 millimoles. 5 millimoles of sodium hydroxide. That's all. You can also say like this. Okay. Students, listen, this is very important, right? If you go for some competitive examination, like whatever competitive examination you write, okay, in those cases, right, this thing will be very, very important, right? This is the definition for molarity. Molarity means number of moles of solute present in 1 liter of solution. Since you are using volume term, liter is the unit of volume, right? So since you are using volume term here, molarity is temperature dependent. I have already told you. Anyway, molarity is temperature dependent. If temperature changes, molarity also changes. Molarity is temperature dependent. Okay. You can also express mathematically like this. Listen. Molarity is equal to number of moles of solute divided by volume of the solution divided by volume of the solution in liter. This will give you molarity. Number of moles of solute divided by volume of the solution in liter will give you molarity. Okay, students, observe this carefully. Number of moles of solute I can represent like this, correct? What is N2? Number 2 represent, students, number 2 represent
Solvent.
Solute.
1 means solvent, 2 means solute. Okay, N2 means, what is N2?
Number of moles of solute.
Number of moles of solute. So instead of writing like this, you can shortly write like this, N2. Volume of the solution, let me write volume of the solution like this. I'll just put solution. Okay, volume of the solution, that should be in liter. Volume of the solution in liter. Okay, you can also write this as number of moles. What is number of moles? Mass of solute by molar mass of solute, right? Mass by molar mass will give number of moles. Okay, and volume of the solution. Volume of the solution in liter. Or I can write mass of the solute is equal to, I'll bring these quantity to the left hand side, right? So I can write mass of the solute is equal to molarity of the solution M into molar mass of the solute M2 into volume of the solution in liters. Students, this is another useful formula, okay, to calculate mass of the solute present in a solution if it is given in molarity. Suppose some solution is given in molarity. If you know the molar mass and the volume, if you know, you can calculate what amount of solute is present. Okay, just for understanding purpose, let me give you a solution like this. Say 2 liter of 0.1 molar, okay, 2 liter of 0.1 molar glucose solution. I have glucose solution. Okay, I have 2 liter of 0.1 molar glucose solution is there. Now the question is, how much, what is the mass of glucose present in it? Aqueous glucose solution, aqueous. 2 liter of 0.1 molar aqueous solution we have. Now the question is, what is the mass of the glucose? What is the mass of glucose is the solute here. So what is the mass of the solute present in the solution? If they ask, okay, listen, molarity is given, volume is given. What is needed now? We have molarity. We have molarity. We have volume of solution. What is the other one we have to find out?
Mass of solute.
Mass of solution we have to find out. Good. But now I know molarity, I know volume of the solution. Which one is required now? Students, I know. Listen, I know molarity. Molarity is given 0.1 molarity. Okay, volume of the solution, yes, volume of the solution also given. Okay, to find W2, you require one more quantity. What is that? What is this? What is M2?
Mass of the solute.
No, W is mass of solute. M2? Molar mass of solute. Students, observe this here. W2 means mass of solute. W2 means mass of solute. Okay, M2 means molar mass of solute. Molar mass of solute. Mass by molar mass will give you number of moles. So this is molar mass. So you need to find out what is the molar mass of glucose. Can anyone tell me the formula of glucose?
C6H12O6.
C6H12O6. Okay, so we have 6 carbon atoms. 6 carbon atoms are there. Okay, for each carbon atomic mass is 12. So 6 into 12, how much? 6 into 12? 72.
72.
Very good. Then we have 12 hydrogen. 12 hydrogen. For hydrogen atomic mass is 1. So 12 into 1 is 12. Then we have 6 oxygen. 6 oxygen atoms. 6 into oxygen atomic mass is 16. 16 into 6?
96.
96. What's the total weight?
178.
180.
180. Okay, students remember.
180.
Yes, students remember. I have given already molar mass of calcium carbonate. What's the molar mass of calcium carbonate?
100.
100. Now I am giving you the second one. These are all very important substance. Often you can see this in problems. So what is the molar mass of glucose? You should immediately say 180. 180 is the molar mass of glucose. Okay, remember the value. So to find W2 means mass of solute or mass of glucose in this solution, right? Mass of glucose equal to molarity, which is 0.1, into molar mass of glucose, which is 180, into volume. Volume is given in liter, so you can write directly. Volume should be in liter. Volume of the solution should be in liter. Okay, so what we'll get? Point 1 into 180 is 18.
36.
36 grams. That's all. Very good, ma. So this solution contains 2 liter of 0.1 molar glucose solution contains 36 grams of glucose. 36 grams of glucose. Okay? Okay, I'll give one more problem to you. You try to find out this value. Okay? It's very quite simple problems. Yeah. 0.1 molar, say I have 500 ml, right? I'll take 500, I'm sorry, I'll write here. 500 ml of 0.1 molar aqueous sulfuric acid. I have aqueous sulfuric acid solution. Sulfuric acid. Aqueous sulfuric acid solution we have. Okay. Find the mass of sulfuric acid present in the solution. Question is this. Find the mass of sulfuric acid, H2SO4. I have given volume. Volume is available. Molarity is available. Which one is missing?
Molar mass of
Yes,
sulfur.
good. First you calculate molar mass. We have 2 hydrogen here. 2 into 1, which is 2. We have 1 sulfur. Sulfur atomic mass is 32. And we have 4 oxygen. 4 into each oxygen atomic mass is 16, so 64. What's the value?
98.
98. Student remembers the next important value. For sulfuric acid, molar mass is 98. நீங்க எக்ஸாம்ல இதெல்லாம் கால்குலேட் பண்ணிட்டு கூடாது. Okay, immediately you should say. For sulfuric acid, molar mass is 98. For glucose, molar mass is 180. For calcium carbonate, molar mass is 100. For water, what's the molar mass of water? H2O.
18.
18. Yes, you should remember these values. Okay, because we are going to use this in many places. Right? Good. Can you tell me what's the mass now? What is the mass?
4.1.
Okay. Right? Molarity is given 0.1. Molar mass is now 98. What's the volume?
1 by 2 liters.
1 by 2. Very
0.5
good.
liters.
Yes. Yes, it is given in ml. So you should convert. Okay, whenever it is given in ml, to convert into liter, you have to divide by 1000. To convert ml into liter, okay, to convert ml into liter, you must divide by 1000. Okay, so you will get 0.1 into 98 to 1 by 2, right? So this is 4.9, correct, students? Am I right? Is the answer correct?
Yes.
Yeah.
Yes, sir.
4.9 grams of sulfuric acid, right, present in 0.1 molar aqueous sulfuric acid of 500 ml. Okay, 500 ml, 0.1 molar aqueous sulfuric acid contains 4.9 gram of sulfuric acid. That's the meaning. Okay. Yeah. Any doubt, students? Any doubt? Do you have any doubt in this?
No, sir.
No doubts.
Right, ma. Okay. So it is right. I stop here. We'll continue molarity in the next class.